So what we're going to talk about is the link between corrosion and sequestering and some of these other issues. So what you've got in those bottles is everybody should have 2 bottles of water, 2 little powder pillows of ferric sulfate, which is iron. You've got a little vial of chlorine, which is the white top, 12.5% bleach, and you've got some SeaQuest, which is the product that Aquasmart makes in the black top. So the first thing we're going to do is take one of the bottles of water and take one of the powder pillows of iron and dump it in there and shake it up. There you go. Yeah, give it a good shake. There you go. What do you guys think is going to happen? Turn brown? Yeah, maybe. Yeah, maybe. There you go. All right. All right, you getting a little bit of color to it, maybe a slight tinge? Okay, so the next thing that you're going to do is you're going to take the bleach. So take the little bottle that has the white cap and sprinkle in a couple drops of bleach into that same bottle that you just put the iron into. However many you want. What do you guys see? Yeah, it's yellow, right? Nobody got purple, right? So what's happening here? Anybody have any ideas? We got any other chemistry people in the audience? Let's hear it, Chris. Little oxidation. There you go. So that's what oxidation does. So if you've got iron, the first form of iron is soluble. And then when you oxidize it, you make it insoluble. And so in the spirit of the holistic comments that we were talking about earlier, that has 2 impacts on your ability to deliver clean water to your customer. One of them is relatively clear, which is nobody wants to drink water that looks like that. The second is a little bit more complex. Any ideas on the second one? Of what effect does oxidizing iron have? Don't do your laundry? Yep, absolutely. What's the reason that you use bleach? Is it to oxidize iron? It's to kill bacteria. So you just used it to oxidize iron, and now you're going to need more of it to kill bacteria. So if you ran a free chlorine test on that bottle, it wouldn't be what you want, because there's no free chlorine left over. All right, so now take the other bottle of water, I should say. And first, the little black vial, or the black top vial that has the SeaQuest in it, go ahead and dump that in. Whole thing, just dump it in. And give that a good shake. All right. After that's nice and mixed, now go ahead and take your iron and put the iron in there. All right, give that a good shake, get that all nice and mixed up. And now go ahead and put the bleach in there and see what happens. So that's the process of sequestration. Basically, the idea is you keep iron soluble and prevent it from coming out of solution. What's interesting is what can happen is iron comes from 2 places. So the first place iron comes from is where? Like manganese.
Just naturally occurring.
Naturally occurring. So it can be naturally occurring. Maybe you're filtering it out. Maybe you've got some kind of oxidation filtration step. The second place is where? Pipes, corrosion. So what you see on the table, the 2 jars that have the pieces of metal sticking in them, what you see there is one jar that's got just water in it, and another jar that's got water plus SeaQuest in it. And we did this about an hour, 2 hours ago, and we'll keep watching those as the day goes on. And you can see the water without the SeaQuest in it probably has a little bit of a yellowish tinge to it, I would imagine. And so that shows corrosion of iron that then puts, or corrosion of mild steel that then puts iron into the water, that then you put chlorine in, and then you oxidize it, and then you have low residuals, and then. So what the SeaQuest is a holistic approach to corrosion control. And there's two ways to look at what we do. The first way is the traditional way, which is you've got categories of types of corrosion inhibitors on the left, and you've got the typical way that those are evaluated as the columns. So obviously you have to work, controlling lead and copper, that's very clear. They should work controlling, steel. Maybe they should work, controlling color and appearance. And then, how much do you use and how much does it cost? And that's usually, the methodology that goes into selecting corrosion inhibitors. What we believe is really important is having a little bit more of a holistic view to this. And so looking at things like how much phosphorus is being put into the water, how much chlorine residuals are you able to generate? Do you form disinfection byproducts? Do you have to switch disinfection because you're forming disinfection byproducts? Maybe you have to go on chloramine in the summer. If you've got clogged up pipes, how does that impact electricity and water flow, pushing the same amount of water through clogged up pipes? Who's measuring that? Workplace EHS, right? How to hire, good people. Well, we were just talking about, don't expose them to really, really hazardous chemicals would be one way, to potentially help. And then, at the end of the day, total use cost. So we engineered SeaQuest to essentially address all of these issues. We've been doing it for a really long time. We've treated a little over 8 trillion gallons of water around the world. And we get a lot of letters back from our customers talking about how we've helped them, and these are some of the things that they say. And then most recently, this is sort of hot off the presses, we are in the process of completing a major year-long study to look back at the performance of SeaQuest versus other things over 20 years at our customers related to the lead numbers that they report to regulators. Because my personal belief is studies are very helpful, very important, but the ultimate test is what numbers get reported to the regulators. That's the ultimate test. And what we see here is on the left, customers that switched from a different mechanism to SeaQuest, their lead numbers went down. And then on the right, the customers that used SeaQuest over 20 years, their lead numbers went down. And in both cases, they're well within compliance of the future EPA limits of 10.